How do we measure success? For the scientists you're about to meet, it starts with uncovering the mysteries of cancer day by day. And eventually, a spark, a breakthrough, a diagnosis, a treatment. And this being science, we can never tell when this is going to happen.
The first paper was published early last year on prostate cancer, region on chromosome 8q24. We looked within that region and were surprised to actually find an independent variant that was not related except for within proximity of that first variant. Other groups have started to replicate those findings as well, and that region actually turns out to contain multiple independent variants that seem to be associated with a wide number of different types of cancer. So we may have identified a region of the genome that is involved in the susceptibility to many types of cancer.
Cytimmune is a small nanotech company based in Gaithersburg, Maryland, and we are helping them in characterization of their material. And they developed a delivery system using gold nanoparticles. By using gold nanoparticles as delivery vehicles, they could show in the animal studies that they could selectively target the tumor and have a local effect. You could take a known FDA-approved therapeutic that is toxic, deliver them specifically to the site of action. By masking the toxicity, you're decreasing the general toxicity, but increasing the local toxicity at the tumor site. So currently they are in clinical trials.
We were a laboratory that identified a biomarker for this bladder disorder called interstitial cystitis. Patients that suffered from it had a very long, strenuous road to diagnosis. We were able to work with NCI collaborators, looking at patient samples, and found this molecule that was a specific marker for this disease. Now we can take this marker, test urine samples from patients, and say, you have interstitial cystitis. So it's really taken what is a very difficult trial for patients into something that is an easy test.
Behind success stories like these are a group of people who are dedicated to the mission of the National Cancer Institute. They all work for the Advanced Technology Program of SAIC Frederick in Frederick, Maryland. Their mandate is to help investigators attain their experimental goals as rapidly and completely as possible with the latest technology. Their mission is to translate research at the bench so their discoveries can be used in clinics.
I would describe the ATP as a broad group of technologies with highly committed and highly practical, educated people wanting to work on your behalf in an applied manner to solve the problems that you have to solve. Supporting the NCI customer, that is our number one priority. But then you look at the breadth of technologies that we've got. There's a real opportunity for outside organizations to access these technologies because it's very difficult for them to access those technologies elsewhere. It goes back to the strategic imperative that the NCI has, in my opinion, and I think it's agreed that they need to translate discoveries from the bench to the clinic as fast as they can.
The powerful combination that makes the ATP unique is the combination of not only the technological tools, but also the diversity of problems that those tools are used to solve.
I will have people come to my office and say, Dr. Veenstra, this is what we want to do. Can your laboratory handle it? Sometimes the answer will be, no, that's not really our specialty. Now, if I was in another institution, I may just have to simply end the conversation there. However, working with the Advanced Technology Program, I could say, come with me and I'll take you to somebody who can address that need. And that's the value of the Advanced Technology Program, having a wide diversity of scientists that have specialization in different areas.
The ATP's strength lies in the powerful foundation of individual scientists who are experts in many fields. As one group, these scientists come together to serve the cancer research community using sophisticated technology and ingenuity to develop better diagnostics and treatments for cancer.
Genetics are really the basis of who we are as organisms. And so determining the variation in a person's DNA is the first step that we can take to determine what's really going on in their body as a whole. So taking and finding those genetic variants is really the first step. Originally, we had assays that were based on single SNPs, so single nucleotides in your DNA strand. So we could look at one SNP per person at a time. And now we're able to look at the whole genome all at once, and we can look at 1 million SNPs per person. So we can generate genotypes for 576 people a week, and that's 1 million genotypes.
The main mission is to help accelerate the transition of the discoveries that are happening. And we have secondary missions towards a standards development, towards structure-activity relationship studies, where how nanomaterial influence toxicity.
Experience in thinking about these sorts of problems on smaller scales has trained us to be able to deal with them on larger scales. We're constantly also finding new ways to use the data.
Our job is to really have the best possible understanding of those technologies so that when we see a problem that needs to be addressed in cancer, we can put our hand up and say, hey, I understand the problem. We have the technology that can assist you in finding the answer.
The scientists at the Advanced Technology Program at SAIC Frederick are committed to providing greater insight to the complex world of cancer. It's a long-term commitment, and they're in it for the long haul. The story doesn't end here. It begins with many individuals who are dedicated to uncovering the mysteries of cancer, even if the end is not yet in sight.
My father went through chemotherapy, and from the time that he was diagnosed to the time that he died, that was within 1 year. And also many of my family members, others too. And so it is very traumatic, not only to the patient, but also to the family. So any therapies that would reduce the general toxicity of material is going to be useful. So nanomaterial have that kind of advantage over conventional therapies.
The edge that we have, if you like, is that we are not singular in our approach. We're plural in our approach. You can do extraordinary things if you've got a group of talented people all on the same page going in the same direction.
Well, it's everyone's dream in the ATP to make some essential connection with one of our NCI client investigators. And the Advanced Technology Program is here in Frederick, poised to help those people with our palette of tools and play a pivotal role in that investigator's work having an impact on cancer.
It is so exciting to be in this new technology, and it is exciting to see actually things happening, things going into the clinic.
There are very few places that I know of, if any, where you could actually access the breadth of technologies that we have here.